Alright, hey everybody, welcome to the first video of our last unit. Again, this is an optional unit. If you've somehow missed the word optional the 4 times you saw it previous to this in the module, if you are taking pre-cal next year with Miss Yoakley, you need to know this material. If you are not, you do not. It's up to you. You are more than welcome to do it if you're bored and looking for something to do, but it's not required. This unit will be primarily videos and notes and practice problems. There will not be any quizzes on this. What I am going to do is leave these up on my YouTube channel along with links to all the documents in case you can't access this Canvas course anymore over the summer. So if you don't finish, that's fine. You can still do them over the summer, or you can review in August when you get close. So those will all be there. So what we're talking about today is multiplying and dividing rational expressions. Rational, we've talked about, they're generally fractions. What makes something a rational expression is it's a ratio of two polynomials. But the one thing that you do need to be aware of is it matters what kind of polynomial it is in the denominator. Numerator doesn't matter, but for it to be a rational expression, it has to have a variable in the denominator. So it doesn't matter what. It can be just 1, it can just be an x in the denominator, it can be something way more complicated, a quadratic expression, something like that, but it has to have at least a variable in the denominator. Alright, now to simplify, there's really 2 basic steps with this. You're going to divide out your common factors, and then you're going to simplify. And it's mostly using our exponent rules that we've already done. Alright, so back in elementary school, you learned how to simplify fractions. And what you're really doing in your head now, if you've gotten to the point where you have this kind of automatic and it can just do it, when you're looking at 15 over 20, your brain generally, hopefully, jumps to, oh, that's 3/4. But what your brain is going through is it's going through this process where you broke it up into small factors, and then you're canceling out what they have in common. So in this fraction, 15 breaks up into 3 times 5, 20 breaks up into 4 times 5, and then you can cancel out the stuff that's the same and end up with 3/4. We're going to be following the same steps, it's just those factors are now going to have variables in them. Otherwise, it's the exact same thing. The one thing that you have to watch out for and be careful with is when you're dividing out those common factors, you have to make sure you're canceling out an entire factor and not a piece of it. If we were in class right now, you would be getting me yelling at you about not wanting to kill kittens. And so this is where this comes from. Some very bored math teachers came up with this meme as a way to hopefully get their kids to remember not to cancel out things in pieces. So what we're looking at here is this rational expression where we've got an x squared on the top and the bottom. And the student has gone through to try to cancel that out, and that's incorrect. What the student would need to do is cancel out an entire factor. And so if you have a plus or a minus sign in between numbers, that entire thing is a factor. What separates factors are multiplication signs. So you can only cancel out a piece that's separated with multiplication signs. And I'll show you what that looks like in just a second. So you're going to hear me randomly yelling at you about not killing kittens. So, you would get that a little bit more if we were in class. But, we'll roll with it for this one. All right, so for this, if we're just going to go through like the basic simplifying. So what we want to do is break that up and then cancel out what we can. So for this one, 4 times x to the 6th is the same as 4 times 6x's. Alright, and then the bottom we have 12x to the third. We could break that into 3 times 4 times x times x times x. Now, if you want to go with your exponent rules, totally fine here. You can just do this mental subtraction and move on with your life. That works for me. But I do wanted to jog everybody's memory on this. When we first started talking about exponent rules this year, we talked about writing this out, and it helped for a lot of you to see it that way visually. So now what we want to do is cancel out the things that are the same on the top of the bottom. So my 4's cancel. I can cancel out one set of x's. I can cancel out a second set of x's. I can cancel out a third set of x's. And then what's left is my answer. So on top I've got 3 x's. On the bottom I have a number 3. And that's it. So x cubed over 3. Alright, so pretty straightforward. Hopefully, like I said, you're vaguely familiar with that, with using our exponent rules. Over here for number 2, same deal. 25 would break up into 5 times 5, and then x squared would be x times x. For 10x to the 5th, it would be 2 times 5, and then 5x's. Cancel out what's the same, so we can cancel out a pair of 5's, pair of x's, second pair of x's. And so what we're left with are all the pieces that are behind. So we have 5 over 2x cubed. And there we go. So we're good. Now, going back to, our kittens up here, all of these were separated by multiplication signs. So I could go ahead and cancel them out. Some of these ones in number 3 and 4 are not. So if you look at number 3, what we want to do here, before we do anything else when we deal with these, is you want to factor first. Before you attempt anything else, go ahead and factor completely. Which does help avoid the killing kittens if you go ahead and just know, okay, I got to factor first. So with these factors, if you are confused and you need to go back and refresh, you can go ahead and take a look in your notebook. This was the boot camp that we did, so this was in between chapter 3 and chapter 4. So it was the hot pink divider page if you have that. So you can go back and look at all of your factoring notes if you need it. For this first one though, we're basically just dealing with GCF. So we've got 2 times x plus 3 for the numerator. For the denominator, that's going to be 4 times x plus 3. Alright, so 2 times the parentheses, and then 4 times the x plus 3. Since that's multiplication, we can cancel out pieces. So we can cancel out that piece and that piece. What we're left with is 2 over 4, which if you simplify that down, you can get 1/2. Alright, over to number 4. For this one, same deal. We're going to be using GCF on top, so 8x goes into both of those. Give us x plus 2 inside the parentheses. In the denominator, there's no GCF. We can't really do anything there. But if you look ahead, or you think about what you did on the top, you know that you have an 8x that you could cancel out if you can make that work. So if you look at 32x, well, yeah, that you can split that up. It's 4 times 8x. So now we've got a couple of things we can cancel. Because we can cancel out the 8, and we can cancel out the x, both of those pieces. And our x, we're going to have x plus 2 over 4 in the numerator. Alright, now for 5 and 6, these are a little more complicated factoring problems. We talked about how to do these using the box and x puzzle before. However, the ones that I'm going to give you, all of the ones I'm going to give you up until the very last problem are the pretty straightforward factoring ones where you learn that most of you guys figured out the shortcut. So I'm just going to use that method. If you need to draw out your box and x puzzle though, go for it. Okay, so for this next one, for number 5, for the numerator, when I go through and factor that out, it's going to factor into x plus 2 times x plus 1. And in the denominator, that's going to be x plus 5 times x plus 2. So the x plus 2's cancel, and we're left with x plus 1 over x plus 5. straightforward. Over to number 6, on that one, the top is actually a difference of 2 squares. If you notice, it's only 2 terms, and so when we have 2 terms, we've only talked about 2 different ways to factor. One is difference of 2 squares, then the other is GCF, greatest common factor. So the top is going to break up into x plus 8 times x minus 8, and then the denominator is going to be x times x minus 8. So we can cancel out the x minus 8's, and we're going to be left with x plus 8 over x. Alright, so this is where my don't kill the kitten comes in again. So this x right here is part of a factor because it's x plus 8. So if it was x times 8, then we could cancel out those x's. But because it's x plus 8, we can't. So we are done. We can't do anything else to that. Well, alright, and here we go. Okay, so for that was just simplifying one rational expression, meaning one fraction. What we're going to look at in the next part is multiplying and dividing. It's basically the exact same steps, it's just you have 2 fractions instead of 1 fraction. So when you're going through these, what you want to do, first you want to factor, then you want to reduce, and then you're going to multiply what's left. And there may not be anything left. It may be very simple and just one thing on top and one thing on the bottom. And that's fine. It's just going to depend on the problem. All right, so first thing we want to do, factor everything, just like we did on the front. All right, so we're going to take out on the top of that first fraction, that's going to be 2x. And then we're going to have x minus 5. And the denominator, that's difference of 2 squares. So we're going to do x plus 5 times x minus 5. For the second fraction, there's nothing we can do on the top. It's already factored. And then on the bottom, I am going to break that up just a little bit because I know I've got a 2x over on the other side that I can go ahead and use. All right, so we factored everything. So now you just want to go through and cancel. Cancel what you can. Oops, sorry about that. All right, so the x minus 5s are the easy ones. Those are gone. Then we lose the 2. And we can cancel out an x. And it doesn't matter whether the variables and numbers and factors that you're canceling out are on the same fraction or on a different fraction. What matters is that one is in the top and one is in the bottom. As long as they are one numerator, one denominator, you can cancel them out, whether they're on the same fraction or 2 different ones. Where it becomes an issue is if you had two numerators or 2 denominators. Then you couldn't cancel them out. They have to be one on the top, one on the bottom. All right, so looking at this, what we have left, we have x plus 3 on top, we have an x plus 5 on the bottom, we have another x on the bottom. So to finish that out, it would look like this. Now, I would be happy with this. However, in pre-cal, I would expect Miss Yoakley to want you to simplify that. And what you would need to do is just distribute. So I would expect her to want to see an answer that looks like this. But they're both correct, they're just different forms. Alright, so now we got to do the same thing over here on number 2. Factor everything, cancel or reduce what we can, and then multiply what's left. Alright, so in the top of the first fraction, that's going to be a GCF. 3x goes into both of those, so it'll be x minus 1. And the denominator, that's a trinomial. So that's going to be x plus 5 times x minus 1. Over in the second fraction, in the numerator, that's another trinomial. It's going to be x plus 5 times x minus 1. And then in the denominator, we have another 3x. So in this one, there's a lot that we can cancel out. We can cancel out our 3x's. We can cancel out our x minus 1's. We can cancel out our x plus 5's. So the only thing we have left is that x minus 4. And that's our answer. So that's it for multiplying. It's pretty straightforward. It's basically the same as what we did on the first page, just with an extra fraction added in. When we get into division, It's actually not that bad either. It's almost exactly the same. The only thing is you have to put one step out in front. Because when you're dividing fractions, way back when you learned how to do that in 4th grade, when you divide fractions, what you need to do is you need to take the second fraction and flip it over. Remember, we would multiply by the reciprocal. And that still holds true now, even if it's got variables in it. And the good thing is once you do that, you turn it into a multiplication problem. We know how to do those, that we just did them. They're super easy. All right, so your first step, you want to multiply by the reciprocal. And then it's exactly the same. Then it's factor, reduce, multiply. All right, so for my first step, that first fraction is going to stay exactly the same. It's going to be 7x over 2x minus 10. Then I'm going to take the second fraction and flip it upside down. So that's going to be x squared minus 11x plus 30 over x squared minus 6x. All right, and then now it's exactly the same as those last two problems we just did. We're going to go through and factor and see what we can get. All right, so 7x, if you want, you can split it up into 7 times x, but that's not a super big deal. In the in the denominator, that's going to be a GCF. So it's going to be 2 times x minus 5. And the top of that second fraction up in the numerator, that's going to be x minus 5 times x minus 6. And then in the denominator, that's another GCF. We're going to take out an x. That's what they both have in common. All right, so here we're going to cancel some stuff out. So can't cancel a 7, can cancel the x minus 5s, and the x minus 6s. So those all cancel. So all we're left with is that 7 and that 2. And so that's our answer, 7/2. As always, if you want to write that as 3.5, sure, go for it. Just make sure that is a terminating decimal, a decimal that stops. If it's a decimal that repeats, don't leave it as a fraction. Okay, so let's take a look at number 2. Same steps. First fraction stays the same. Second fraction, we're going to flip and multiply. All right, so that's our first one. Now we got to go through and factor everything. All right, so that's going to give us 4 times x. In the denominator, we're going to do a GCF, and so that'll be 5 times x minus 4. In the numerator, the second fraction, that's going to be x minus 4 times x minus 2. And then in the denominator, we're going to multiply, that's going to be a GCF, and we're going to multiply, or pull out the x. So we have x times x minus 2. Alright, I hear a lawnmower going in the background. Sorry, y'all. Hopefully that's not too distracting. Okay, so we have x and x, that cancels. X minus 4's cancel. And then x minus 2's cancel. So all we're left with is that 4/5. Alright, so that's the general principle when you're dividing. Just take the second fraction, flip it over, turn it to multiplication. All right, we're going to do one more. This one has a slightly more complicated factoring pattern, which is definitely good for us to review. But one thing I want you to notice, what looks a little weird about this one, you look at the second rational expression, it's not a fraction. So the first thing we need to do is make it a fraction. So I just put it over 1. Then we can follow our same steps. So first fraction stays the same. Second fraction, we're going to flip and multiply. All right, so for the factoring for that first one, the 2x squared plus 3x minus 5, probably going to want to do an x puzzle and box for that. Alright, in case it's been a hot minute. So we've got 2x squared right there, negative 5 goes here, and then we've got to use the x puzzle to figure out what's going to go in these two boxes. So across the top, that's going to be negative 10x squared, because I multiplied the first term times the last term. The bottom down here is 3x. So I need something that will multiply to be negative 10x squared, but will also add up to be positive 3x. And what's going to work is 5x and negative 2x. So those fill in the boxes. And again, it doesn't matter where you put them. You'll just get your parentheses in a different order than I do. And then what we're going to do is we're basically going to go through and find GCFs for each of these. So for that first row, the 2x squared and the negative 2x, they both have a 2x in common. So if that's 2x, and I need to multiply it by something to get 2x squared, that means I have to multiply it by x. And then for the second term in that row, I have 2x, I need it to be negative 2x, so that means I need to multiply it by negative 1. Alright, and then the last one, we've got an x up top, it needs to be 5x, so that means I have to multiply it by 5. And then the last thing you want to do is double check. If we do 5 times negative 1, does that give us negative 5? Yeah. So 2x plus 5 times x minus 1 is what we get when we factor that out. Alright, so I'm going to take that back over here. 2x plus 5 times x minus 1 over 6 times x. The 1's still going to chill. We can't do anything to it. And then in the denominator, we're going to do a GCF. We're going to pull out an x. So we have 2x plus 5. So in this one, there's not a lot that we can cancel out. The only thing we can cancel out is that 2x plus 5. So why can't we cancel those x's out? They're the same. Well, they are the same, but they're both in the bottom of the fraction. They're both in the denominators. Remember I said that one of them has to be on top and one of them has to be on the bottom for us to be able to cancel it. So what we have left, we have an x minus 1, we have a 1, we have our 6x, and we have an x. So what we need to do to get our final answer is just multiply all of that together. You just go straight across the top and straight across the bottom. So x minus 1 times 1 is just x minus 1. On the bottom, 6x times x would give us 6x squared. Alright, so that's the first part of Unit 3. This is multiplying and dividing. Tomorrow we're going to use this to solve equations. So we're going to need to get common denominators and then try to solve using these same properties that we just figured out. I'm going to post one of these videos a day over the next couple weeks, but like I said, I'll be putting the information up on my YouTube channel and I'll leave it there. So if you don't get to it right now, that's fine. You can still pick it up later. All right, everybody, I hope you're having a good week. Talk to you later. Bye.